Hello children, welcome to AIMS India's online classes. In today's class, from mathematics subject, factorization topic we are going to discuss. So here children, so first we have to know what is factorization. What is the meaning of factorization? You might be knowing some normal factors. Suppose we have 6. 6 can be written as 2 into 3. So 2 is a factor of 6, 3 is a factor of 6. So factorization, it is a mathematical process that is used to break down bigger numbers into smaller numbers. Now here 6 is a bigger number. We are breaking it down to smaller numbers like 2 and 3. That process is called factorization. That process is called factorization. But here we are going to do the same process in terms of expressions, not only numbers. In terms of expressions, we are going to apply this concept. Suppose if we have a square minus b square, it can be written as a plus b into a minus b. So here a square minus b square is an expression which can be written as a product of two smaller expressions. So these two smaller expressions are factors of the bigger expression. Factors of the bigger expression. So like this, finding the factors is called factorization. For the complex expression, or for the bigger expression, finding out its factors in terms of product of smaller expressions with smaller degrees, this process is called factorization. So as we know in the process of numbers, same process we have to apply for the expressions also. So actually, factorization, it's a reverse process of multiplication. If we multiply a plus b into a minus b, if we multiply, we will get the product. We will get the product. If we multiply two simpler expressions, we will get a bigger expression. Means this is multiplication. So in factorization, what we will do? Reverse we will do. Bigger expression, we will divide into smaller expressions. In multiplication, smaller expressions are multiplied to form a bigger expression. But in factorization, bigger expression is split into two individual or smaller expressions. So that's why we can call factorization as reverse process of multiplication. Reverse process of multiplication. Let's see the example children. So here 3x into 4x minus 5y. So here we have an expression 3x and we have another expression in bracket 4x minus 5y. We are doing the product of these two. So we are getting a bigger expression with higher degree. Here the degree of x is 1, here is 1, but here it is 2. With higher degree, we are getting another expression. So this is an example of product. But in factorization, what we will do? This bigger expression splitted into two smaller expressions. So factorization is a reverse process of product or multiplication. In second example, x plus 3 into x minus 2. Two expressions we have multiplied and we have got x square plus x plus minus 6. X square plus x minus 6. So this is called product. But in factorization, what we will do? This bigger expression splitted into smaller expressions. Third one also, 2a plus 3b. This is first expression. 2a minus 3b, second expression. Both we have multiplied. we got third expression. But in factorization, what we will do, the third expression will be divided into 1 and 2 expressions. It can be written as product of 1 and 2 expressions. So factorization is a reverse process of multiplication. Reverse process of multiplication. Next children, different types of factorization methods. Next, we have to see what are the different types of factorization methods. So, first one is factorization by taking out the common factor. So, by taking out the common factor, we have to do factorization. That is the first method. Just by observation, just if we see the expression, just by observation, we can know or we can identify some common factors in each term. We have to take them out as common factor. That is one thing. Or we can divide each term by the common factor. We can divide each term by the common factor. So here children, if you observe the expression, on your observation, you can find some common factors. You have to take them out. Or you have to divide each term by the common factor. In that way, we can do the factorization by taking out the common factor. Let's see the example, children. Suppose we have 3x square plus 6xy. So this is the expression for which we have to do factorization. Means for this bigger expression, 3x square plus 6xy, we have to find the factors. So here, this 3x square can be written as 3 into x. 6xy can be written as 6 also can be written as 2 into 3 into x into y. We can write 3x square like this and 6xy like this. If you observe here, 3 is common, 1x is common. So 3x is the common factor. So from the given expression, if you take out the common factor 3x, so then what is remaining here? In first term, only x is remaining. In second term, 2 is remaining, y is remaining. So 2y is remaining. So for the given expression, the factors are one is 3x, another one is x plus 2y. These two are the factors of given expression. So how we have solved? By taking out the common factor. By taking out the common factor, we were able to find the factors of given expression. Now let's see the second example. Ax square, bx square, ay square, by square. Ax square can be written as a into x, bx square, b into x, ay square, a into y, by square, b into y. So if you see the first two terms, x square common, 2x common, 1x here, x into x square is common in first two terms. In next two terms, y square is common. So what we can do, from these first two terms, x square we can take it out, So here a will remain, so here b will remain. So we can write it as x square into a plus b. That is one term. This two terms, we have simplified two terms into single term by taking out the common factor. Next, ay square plus by square, y square we can take it out. So a is remaining here, b is remaining here. Y square into a plus b. So now four terms are there. by taking out common factor. This is the first term we have got. This is the second term we have got. But in this first term and second term, here also a plus b is there. Here also a plus b is there. So a plus b is common. So this time we can take a plus b common. This a plus b we can take common. So in first term, x square is remaining. Second term, y square is remaining. So this expression, if it is written as a factors, a plus b is one factor, x square plus y square is another factor. If we multiply these two factors, then the original expression will come. So this is the first method, children. What is the method? Taking out the common factor. Taking out the common factor. Next, children. So factorization by grouping the terms. Grouping the terms. So sometimes just by taking out the common factor, it may not be possible to do factorization, or for all the terms it may not be possible to take out the common factor. So what we will do, like this question, we cannot take common factor for all the terms at a time. So these two we have grouped, these two we have grouped. So for our according to the question, for our convenience, so what we can do, we group the terms to have a common factor. Means the terms which are having the common factor, that we can group them as a single group, and common factors are taken out from each group. Common factors are taken out from each group. So this is the expression here. So a square plus 2b plus ab plus 2a. We have four terms here. From four terms, there is no common term for all the terms. So what we will do, a square plus ab, we will group into one first group, 2b plus 2a, second group. Like that, out of four terms, by taking two terms each as single group, we have got two groups. In first group, in a square plus ab means, a square means a into a plus a into b. So one a is common. One a we can take common, take it out. So another a is remaining here in the first term. In second term, b is remaining. So we can write it as a into a plus b. In second one, here also 2 is there, here also 2 is there. 2 we can take it out. So a will remain here, b will remain here. So if we take 2 out, a plus b will remain. Now this is the first group, this is the second group. In two groups, a plus b is common. So a plus b we can take it out. So here a is remaining, here 2 is remaining. So a plus b into a plus 2. These two are the factors of the given expression. So in this way, we can group the terms and we can take the common factor out. Another example. 6 p.m., 9 mq, 8 pn, 12 qn. We have four terms like this. First two terms, we have m here. These two, one group. Next two terms, we have n here. We can take them into one group. Now 6 p.m. plus 9 mq. M is common, or 6 p.m. means 6 p.m. plus 9 mq. 6 can be written as 2 into 3 p.m. plus 9 can be written as 3 into 3 mq. So 1 3 is common, 1 m is common. So what will remain here? 2p will remain. Here 3q will remain. 3q will remain. So if you take 3m outside, 2p will remain plus 3q will remain. Next, in second one, 8 pn plus 12qn. This can be written as 2 into 2 into 2 into p into n. First one. Second one can be written as 2 into 6. We can write again 2 into 3. 2 into 2 into 3 we can write into q into n. So 1 2 is common. Another 2 is common. 1 n is common. So 2 2's, 1 n is common. So 2 into 2 4, 4 into n 4n. So 4n is the common term. So 4n we can take it out. So what will remain here? 2p will remain. Here 3q will remain. So 2p plus 3q. Like this we have simplified. But in this first group and in this second group, now 2p plus 3q, 2p plus 3q is common. So if you take 2p plus 3q common out, then here 3m is remaining, here 4n is remaining. Now these two are the factors of given expression. So in this way, we can group the terms, children. Then we can take the common factor out from each group. This is the second method, children. This is the second method. Okay, children. Next, you are having theorems, factor theorem, remainder theorem are there, that we will discuss in our next video. Okay, children, that's all for today, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving the latest updates, children. You can also visit our website www.aimstoday.in for information regarding other online classes, quizzes, worksheets, activities, coding skills and all. Thank you, children. Have a good day.